f of x equals to ax square plus bx plus c. It is given, and it is also given, and it is also given f of x plus 1 equal to fx plus x plus 1 is an identity. Is an identity. Now, how to find f of x plus 1? Just in place of x, the input should be x plus 1. Just x will be replaced by x plus 1. So we write here a into x plus 1 whole square plus b into x plus 1 plus c equal to ax square plus bx plus c is given plus x plus 1. Now this on simplification, x plus 1 whole square minus x square plus b into x plus 1 minus x, cc cancelled out, equal to x plus 1. Now this gives us a into 2x plus 1 plus b minus x minus 1 equal to 0. Which one further simplification gives 2a minus 1 into x plus a plus b minus 1 equal to 0. Which will be an identity which will be an identity when 2a minus 1 equal to 0 implies a equal to half and a plus b minus 1 equal to 0. Now this implies b equal to 1 minus a. Now on substituting the value of a, on substituting the value of a, we get b equal to 1 minus half equal to half. Hence, a equals to half, b equals to half, which is required. And c can be any real number. Here required values of a and b are half and half. Fx equals to x square plus ax plus b and given f of 1 equal to 1, f of 2 equal to 2, and we have to find the value of f of 3. So this is we need to find. So then what we can say that f of 1 means 1 plus a plus b, which is equal to 1, and this gives us a plus b equal to 0. And f of 2 equal to 2. Now this gives us 4 plus 2a plus b equal to 2. Now this gives us 2a plus b equal to minus 2. This is equation 2. Now we will solve 1 and 2. On solving 1 and 2, we get a equal to minus 2 and b equal to 2. So the expression fx will take the form x square minus 2x plus 2. Now f of 3 will be 3 square minus 2 into 3 plus 2. That gives us 9 minus 6 plus 2. That gives us 5. Who is the required answer? F maps from R to R. Fx equals to x for all x belongs to R. And G maps from R minus set containing 0 to R. And Gx equals to 1 by x. So we represent f, which is a linear function. So its domain must be R, x, x prime origin, y prime. Since it is y equal to x, this is the line we are getting, passing to the origin. Here, largest possible domain of A is R. Therefore, we can write it as domain of F is R. Now we come to this one, and here we can mention F maps from R to R, Fx equals to x. That has been represented here. And here G maps from R minus set containing 0 to R. So here we take this x, y, x prime, y prime origin. These are rectangular hyperbola. This is y equal to 1 by x graph. Now this is defined for all x except 0. All x belongs to R except 0. So here domain of G is R minus set containing 0. Now f plus g of x equal to fx plus gx, provided the domain of f plus g equal to domain of f intersection domain of g. Now fx is x plus 1 by x. Now domain of f plus g will be R intersection R minus 0. That gives us R minus set containing 0. R intersection R minus set containing 0. That gives you R minus set containing 0. That is the required domain of this one. That is x is not equal to 0. Similarly, f minus g of x equals to fx minus gx. This will be x minus 1 by x, but provided domain of f minus g is domain of f intersection domain of g, that is R intersection R minus set containing 0, and that is R minus set containing 0. F of x equal to under root of x plus 1, gx equal to under root of x minus 1. These are the two functions given. So at first we'll find the domain of these two functions. So we start in this way, the given rule of correspondence, which we have denoted as fx equal to root over of x plus 1 will be defined with the largest possible domain when x plus 1 greater than equal to 0. So x greater than equal to minus 1. Therefore, domain of f equal to minus 1 comma infinity. Similarly, domain of gx equal to 1 comma infinity, as for all x belongs to 1 comma infinity, x minus 1 greater than equal to 0. This implies root over of x minus 1 greater than equal to 0. Therefore, gx is defined. Now what we need to find out, we need to find the function, we have to define the function f by g of x, which is fx by gx, that is root over of x plus 1 by root over of x minus 1, provided the domain of f by g equal to domain of f intersection domain of g minus those values of x for which gx is 0. Now, the intersection part, one is saying minus infinity to minus 1 to infinity, another is saying 1 to infinity. So the common region will be 1 comma infinity minus gx is 0 means x minus 1 equal to 0. X such that x minus 1 equal to 0. So this will be 1 comma infinity. That is the domain for the f by g in of x. Now, this part we can understand that the intersection of df and dg equal to 1 comma infinity, that can be more clearly understood by taking a number line. If we take here a number line for the domain of f, it starts from minus 1 and it extends up to infinity. And for domain of g, it starts at 1 and this also extends up to infinity. So the common region we can see, the common region means where we have red and green both, that is from 1 to infinity. And here we have to eliminate which value of x for which gx is 0, 1. So we got the domain of f by g as this one and is defined by this expression root over of x plus 1 by root over of x minus 1. Similarly, for the function g by f of x, that is gx by fx, and which is root over of x minus 1 by root over of x plus 1. Now this will be true when domain of g by f equal to domain of g intersection domain of f minus those values of x for which fx is 0. In the intersection part, we have dg, that is domain of g, intersection domain of f, that gives us 1 comma infinity minus those values of x for which x plus 1 equal to 0. Now in this we don't have in this interval we don't have minus 1, so the domain is 1 comma infinity only. Now the next part of the question has asked that we have to find f by g of 1. Now is not defined, as 1 does not belong to the domain of f by g, and g by f of 1 is equals to under root of 1 minus 1 by under root of 1 plus 1, that is 0. So that is the required answer. It is given fx equals to 3 minus mod of x minus 3. Now, we know that for all x belongs to R, x minus 3 belongs to R. This implies mod of x minus 3 is greater than equal to 0. This implies minus mod of x minus 3 is less than equal to 0. And this implies 3 minus mod of x minus 3 less than equal to 3. And therefore, or this here this implies fx less than equal to 3. Therefore, we can say that fx belongs to minus infinity comma 3 closed. So range of f equal to minus infinity comma 3. F composition of G, composition of H, X equal to, we have to find, it is given fx equals to x by x plus 1, gx equals to x to the power of 10, and hx equals to x plus 3. Okay, so what we have here, gx, we have got fx is what, x by x plus 1, gx is what, x to the power of 10, hx is x plus 3. We have to find f composition g of x. So here what we have, f composition of g composition of hx, and that can be written as f of g of h of x. Now that means what? F of g of hx. So f of g of hx is what? X plus g. So we substitute the value. Now, when g will take up this as the input, it is x to the power of 10. So the output will be what? X plus 3 whole to the power of 10. Now, when f take this one as the input, when f we take this one as the input, what we get? We take it here, x plus 3 to the power of 10 by x plus 3 to the power of 10 plus 1. It is given fx equals to 4 to the power of x by 4 to the power of x plus 2. And we have to show here f of x plus f of 1 minus x equal to 1. And hence we have to show another expression, that is the value of the another expression. So that will come to after proving this one. That is here f is given, f of 1 minus x is, we have to find out by using this concept, that is f of 1 minus x, that is when the input is 1 minus x, it is 4 to the power of 1 minus x by 4 to the power of 1 minus x plus 2. Now if you simplify this one, it is 4 by 4 to the power of x by 4 by 4 to the power of x plus 2. So if you multiply numerator and denominator by 4 to the power of x, we get 4 by 4 plus 2 to the power 2 into 4 to the power of x. Here 4 to the power of 1 by 4 to the power of x, here 4 to the power of 1 by 4 to the power of x plus 2. So we have taken the LCM, or you can say that 4 to the power LCM the denominator, and we have got this, and then this is cancelled out. Now, if we add these two equations, what we get? But before that, we can do one thing. We can simplify this one further. How? You can see that 2 can be taken common. So we can write this as 2 by 2 plus 4 to the power of x. Now, fx plus f of 1 minus x. 4 to the power of x by 4 to the power of x plus 2. 2 by 4 to the power of x plus 2. Now 4 to the power of x plus 2 by 4 to the power of x plus 2, and that gives us the result as 1, which is the first part of the proof. That is fx plus f of 1 minus x is equal to 1, which is shown. Now, hence, we have to show that the expression f of 1 by 1997 plus f of 2 by 1997 plus f of 3 by 1997 plus f of 1996 by 1997 equal to 998. So this is what we have to show. Now we here it is clearly mentioned that hence show that. Hence show that means we have to utilize the previous result which you have got, that is fx plus f of 1 minus x is what? Equal to 1. So we have to utilize this one. So if we utilize this, what we get? That is this expression with the LHS part we can write as f of 1 by 1997 plus we can take another one 1996, the last term, by 1997 plus we can take another pair f of 2 by 1997 plus f of 1995 by 1997 plus, like this way if we continue, what we get? F of, so when we come to the because 1 with 1996, 2 with 1995, similarly 3 with 1994. So if we continue like this way, and if we divide this by 2, what we get? That is 998 by 1997 plus f of 999 by 1997. This we get. Now we can make pair this one plus this one, this one plus this one, this one plus this one. Now this pair we can further express as f of 1 by 1997 plus f of 1 minus 1 by 1997, which is the first term, plus next one f of 2 by 1997 plus f of 1 minus 2 by 1997 plus this is continue, and here f of 998 by 1997 plus f of 1 minus 998 by 1997. Now here if we take the pair again, which we have taken already, what we get? That the first term will give us 1, next term will give us 1, and even the last term, which is the 998th term, that is clearly understood because like this we are going and we are coming to this term. So that will be what? That will be 998th term, 998th term. So how many one we are adding up here? We are adding up here 998 terms, and that gives us 998, which says that fx equals to cos ln x. Now, when fx is cos ln x, f of y equal to cos ln y. You can express this one as cos of log of x base e also. Here cos of log of y base e. This can also be written. Now the given expression is fx into fy minus half of f of x by y plus f of xy. Now what is fx here? Fx is cos of ln x into cos of ln y minus half of cos ln x by y plus cos of ln x. Now from here what we can write? Cos ln x into cos ln y minus half of cos ln x minus ln y plus cos ln x plus ln y. This gives us cos ln x into cos ln y minus half of, we can apply here cos a plus b plus cos a minus b, that is 2 times cos a cos b. On simplification, what we get? Cos ln x into cos ln y minus cos ln x into cos ln y, and that gives us 0. F of x equals to sin x. G of x equal to x square. And hx equal to log x base e considered. And here we have to find h of g of f of x, which is h of g of fx, means h of g of fx is sin x, so we can replace the value of fx by sin x. Now h of g of sin x, when the input is x, it is x squared, so when it is sin x, this will be sin x whole square. Now h of sin x whole square, that will be log sin x whole square. Now this can be written as 2 ln mod sin x, which is the required answer.